Hello students, welcome to this session. I have just solved this paper NEET test 67. The paper was uploaded around 11:30 and it's almost around 12:30 that I am doing this paper after finishing it. This analysis, this paper is not an easy one. From the last few tests, this appears to be quite a tough one. It has questions from X-rays, it has some questions which are not generally asked, and this question 11, this one of the question I personally don't know what should be the correct answer. I've given the explanation they have given plus my view also. I'll also find it out and will post you the correct logic of this question in the coming sessions. Plus what I can make out, there are 8 questions which are tough, 18 are easy, 19 are medium. This paper might be very tough for some students. So again I say that for the average student here 120 would be a good score. If we get 120 plus in this paper it's good, and for very good students the score should be 150 plus. But this paper might be heartbreaker for someone because there are many questions which might be, let's say, left you wondering how to solve them. So let's see the paper. So let's start the paper. The K alpha X-ray emission line of tungsten occurs at this wavelength. The energy difference between KL and, so you know the K alpha corresponds to the difference of these two levels. So directly I can say that delta E is the energy of the photon, that would be equal to hc by lambda. So what I can write is 1240 eV nanometer, that we usually write, into 21 into 10 to the power minus 3 nanometer you can write. So what it becomes 1.24 upon 21 into 10 to the power 6 eV. I can write like this. So this is mega eV, and this mega eV, if I do this, it won't be in mega eV, like it would be a very small value. If I do this, it is point, then again 0, then 124 would be, let's say, the 5 times. So 0.05 into 10 to the power 6, or if you go ahead it would be some higher value or something. So it is, let's say, 59 kilo electronic volt would be the, it would be something like that. So it would be 59 kilo electronic volt I can go for. Next one. The binding energy per nucleon of 7 lithium and 4 helium are given. Okay, in the nuclear reaction the value of energy Q is, so Q simply would be final binding energy minus initial binding energy. Whenever you are writing with respect to binding energy, if the energy is released, that means the final product is more stable, it will have more binding energy. So what it will have, 2 into the binding energy of helium, that would be 4 into 7.06. okay, this is the 1 multiplied by 2 minus lithium, what we have, 7 into 5.60. because this is not associated proton, so its binding energy won't be included there. So what we have, 8 into 7.06 minus 7 into 5.6. so do the calculations. 8 6 are 48, 8 7 are 56, 7 6 are 42, 7 5 are 35, and 4 39.2. so what you have, this is 8, this is 2, 16 minus 9, that is 7, 4 minus 3, 17.28. so approximately 7.3 MeV that I'll go for. So next one, after second we'll go for the third one. The smooth and similar right angle prism are arranged on a smooth horizontal plane as shown in the figure. Lower has a mass 3 times that of the upper. They are held in an initial position as shown and released. As the upper prism touches the horizontal plane, the distance moved by the lower prism is. Okay, so what is the distance moved by the lower prism? So first of all, let's say if I see with respect to this, it will move a distance which I can say is, this distance you can make out is b minus a horizontally. So this is the relative distance. So you have done this. Let's assume it goes by distance x. So what we will have, let me draw it with some other color. So let's say it goes by distance x like this. So what we will have, it goes by distance x. I have drawn some larger distance. Let me draw it here. So this was the initial one. Okay, this was the initial one. Now this one, let's say, goes somewhere here, and now it comes here. So finally this edge comes here. So what we say, if this shift by x, this is actually shifted by what we this, b minus a minus x distance. So again, because CM will not shift horizontally, it can shift vertically but it won't shift horizontally. What I can have, mass of the upper prism into distance moved is b minus a minus x forward would be equal to the mass of the lower prism into distance x. That is what I can write. So simply this x will come out as mass of upper into b minus a divided by mass of upper plus mass of lower. That you can directly write if you have done such question of Planck and everything else. And what is given? The lower has a 3 times mass, so let it be m, that it becomes m plus 3m into b minus a. So now we will go for b minus a by 4. That is the answer. So b minus a, oh sorry, I have written it wrong. It is a minus b, not b minus a. Initially I wrote it wrong. A is the bigger one, so it should be a minus b. It was my mistake here. So it would be a minus b. So reverse it, so reverse it, and it will also be reversed. So it would be a minus b by 4 I can write. Okay, next one. So this was D1. Now the next one. A girl of 50 kg mass stands on a railroad car of mass 75 kg going with speed 20. Now the girl begins to run with a velocity of 10 with respect to car in the same direction. Okay, the velocity of the car, again the cm's velocity remains same. So relative to this it becomes 10. So let's say the velocity of car becomes vc. So what I can write, initially both were moving with same speed, so initially 50 plus 75 into 20, and final momentum will be same. So the car's velocity will be 75 into v of car plus girl's velocity is 50 into v of car plus 10. That is what we can write, because it was moving relative to 10 in the same direction. Now what we will have, this is 125 into 20, that again if I write would be equals to 75 plus 50 into vc, that is 125 again, plus 50 into 10, that is 500. So what we get, this will be 125 into 2, that is 250, 2500 minus 500, that is 125 into vc. So the vc comes out to be 2000 upon 125. So this would be 16. If you solve it, this is 16 meter per second, because 1000 upon 125 is 8, so 2000 upon 125 is going to be 16. So go for option C. Next, a car round on unbanked curve of radius 92 meter without skidding at the speed the smallest possible coefficient of static friction is. So what we can say, the required centripetal force mv square by r is provided by fx, that should be less than equal to mu sn, which is mu s mg here. So mu s should be greater than equal to v square by rg here. So it should be greater than v square by rg. So v square is 26 into 26, this is 92 into 10. So what we get now, 26 and 92, let me cancel it, this is 13, this is 46, again cancel, let's say this is 13, this is 23, so it is 13 into 13, sorry, it would be 169 upon 230. So if I do this, it is approximately point. So if I do this 23 table, that is 23 5s are 115, and if I add 46 to it, it will again be, so it would be 0.7 something. So go for 0.75, no doubt about it, go for option A. Next, a particle travels along the arc of a circle of radius r. Its speed depends on the distance traveled L, as v is equal to a rate L, where a is a constant, not acceleration. The angle alpha between the vectors of total acceleration and the velocity. Okay, so total acceleration and velocity, let's say if this is velocity, total acceleration is like this. So we have this component as AC and this as AT. So this angle you are required, so tan theta we know is equal to AC upon AT, that we have to find. Now first of all, v is equal to a root L. So v is, let's say a root L, that is S, what we can write. So v, I can write it as dl by dt, because it is the distance. So dl by dt is a root L. So dl by root L is equal to a dt. So if I integrate it from 0 to t, from 0 to L, this would be 1 by root L. Integrate, it would be 2 root L. It would be then 2 root L. So it would be 2 root L would be equal to AT. So L is equal to AT square by 2. So what we get, v is a times root L becomes AT by 2. So v becomes a square t by 2. So this is v. So first of all, what is AT? Tangential acceleration is the rate of change of speed, that is dv by dt. That basically comes out as, what it comes out as, it comes out as a square by 2. This is a square by 2. Now what is AC? AC you know is v square by r. So v square by r is a small r here, so v square would be going, because it is in L term, so I can take it from there, that is a square L by r. So tan theta is AC by AT. So what is AC by AT? A square L by r divided by a square by 2. This goes, so 2L by r tan inverse. We can go for this angle alpha, tan inverse 2L by r directly using the information given here. Next one. An ammeter and a voltmeter of resistance R are connected in series. Voltmeter of resistance R are connected in series to an electric cell of negligible internal resistance. The readings are A and V respectively. If another resistance R is placed in parallel with the voltmeter, then. So what we have, this is a battery and we are connected in series. Okay, so this is ammeter, this is voltmeter which has some resistance. Now you have connected this R in parallel. So what happens? Overall this resistance will decrease, it will become half. So overall the circuit resistance will decrease. So resistance of circuit will decrease. So it's clear current will increase. So ammeter reading is definitely going to increase, first of all. Second, because before that the ratio of the resistances was different. Now this ratio of resistances is decreased, so its value increases. So the voltage drop across ammeter will increase, so voltage drop across this voltmeter will decrease. You can remember this was V1 plus V2, and this V1 V2 was this R1 upon R2. Now this R2 factor has decreased, so that V2 proportion will decrease. So what will have, ammeter reading will increase, but the voltmeter reading will decrease. Now the next one. 5 resistances are connected as given in the figure. The equivalent resistance between A and C. So if you see this 4, 6, 8, 12, so it's a balanced Wheatstone bridge. This is 4:6, this is also the 2:3, this is also 2:3. So this 10 ohm is only here for showpiece, it would be no role, remove it. Now 4 and 6 take it in series 10, this take it in series 20, and they are in parallel. So the answer would be 10 into 20 upon 10 plus 20, which is 30. So answer comes out to be 20/3. So it's an easy one because the bridge is balanced. If it was unbalanced, it would have been a tougher one. Now in the circuit depicted in the figure, a conducting wire HE is moved with constant speed V towards left. Okay, the complete circuit is in a uniform field perpendicular to the plane inwards. The current in HKDE, which is HKDE, okay, this HKDE is. So what will happen now? So first of all, what we'll have here, the current in HKDE is, so first of all, because it is moving, it is a perpendicular, so V cross B, if you do it, it will act as a battery like this. This will be like a battery, V cross B, this V will be inward, so EMF would be equals to BVL. So this EMF is constant, so this EMF is constant, so the potential difference across this capacitor will also remain constant, so its potential remains same, so its charge remains same, so no charge will flow. So the current in this arm is 0, current will only flow in this HARE, yeah, you can say EB AH branch, not in that branch. So the required current is going to be 0 because capacitor voltage is going to remain constant as it moves ahead. Okay, so if some resistors or some other thing is given, we would have thought otherwise. Here we will directly assume it will initially get charged, and once it's charged, it won't allow any current to pass through, so it would be 0 as per this question. Next, a metal disc of 100 centimeter radius is rotated at the speed in a plane at right angle to an external field. The EMF induced between the center and the point on the rim. So this you have done many times. You directly know E would be equal to B omega R square by 2. We have done it many times. You have done the derivation also. Again, I am telling you, take this line, take it with respect to this, go by distance x, take a element dx. Its velocity would be omega x. So for this small, you will write dE is equal to B dx into speed, which is omega x, and integrated, it comes out 0 to r, it comes out as B omega R square by 2. So what is the induced EMF? B is 0.05, omega is 60, r square, that is 1 meter, 1 by 2. So what you have, 60 by 2, that is 30, 30 into 0.05, that is 3 into 0.5, that is 1.5 volt. So as per my calculation, it should be 1.5 volt. It is. Next, two similar point charges Q1, Q2 are placed at a distance r apart in air. Okay, the force between them is F1. A dielectric of thickness, slab of thickness T, which is less than R, and dielectric constant K is placed between the charges. Then the force between the same charges is F2. The ratio. Now, this question is slightly a tougher one. Frankly, what I believe, let's say if these are two charges Q1, Q2, and if you place a dielectric like this, so what will happen now? So because of this dielectric, it's generally what the people do in this solution. They basically say this dielectric, let's say, is of thickness T and dielectric constant K. It is equivalent to a vacuum distance of T root K. going by the analogy of that force expression, that become k times r square, so T times root k. So if I go by that analogy, so in that F2 expression I will have k q1 q2 upon effective vacuum distance will become, it would be, let's say, what we can have, r minus T was full plus T root k and this whole square, and F1 was k q1 q2 by r square. So if I go by the ratio, what we need to know, the ratio of, let's say, F1 is to F2, that will come out as r minus T plus T root k upon r whole square. That is the usual explanation that we give, and the answer given is like this. But frankly it's quite confusing, because when we simply say because of this dielectric, now it's tough to comment, but why feel that the electric field at this point is not affected because of this dielectric. So still I believe if it is a partially filled one, the force will still remain the same, the ratio should be 1. So it's a tricky one. The answer is given as C, but I personally go for 1. So I'll also find it out what should be the correct way, but for the time being go with what they have given, because that is what you can see mostly in the sources. Now 12th, two identical conducting spheres carrying different charges attract each other with a force F. When placed in air medium at a distance d apart, the spheres are brought into contact and taken to their original position. Now the two spheres repel each other with a force whose magnitude is equal to that of the initial attractive force. The ratio between the initial charges of the sphere is, okay, so initially they were attractive, so let's say first one was q1 and let's say second one was minus q2. So the magnitude of force was k q1 q2 by r square. Now on touching them, let's assume, let's say q1 is a greater one, something like that. So now the charges on both would be q1 minus q2 by 2, and now the force is still the same, that is F, that is k q1 minus q2 by 2 whole square by r square, that is equal to F k q1 q2 by r square. That is what you are getting. So what we get now, r square kk goes, so q1 minus q2 by 2 is equal to root q1 q2. That is what we are getting now. So what would be the ratio between the two charges? So what we can say simply, if q1 by q2 minus 1 would be equal to 2 times, if we divide it by, let's say, q2 here, it will become root q1 by q2. So let's say this ratio be x. So x minus 1 is 2 root x. So square it up, what we will get, x square minus 2x plus 1 is equal to 4x. So it becomes x square minus 6x plus 1 equal to 0. So x come out as minus 6 plus minus root of b square, that is 36 minus 4 upon 2. So it comes out as minus 6 plus minus root of 32 by 2. So take this common, this would be minus 3 plus minus, it would be root 8. So it would be minus 3 plus root 8, or what we can have, because the ratio should be negative. The ratio should be negative, so minus 3 plus root 8 will also work, and minus 3 minus root 8 will also work. So I'll go for option C in this particular case. Next one, which of the following graphs correctly represents the variation of g on the earth? Now this is the easiest one for you. Inside the earth it's linear, and then it is what you say 1 by r square, so go for option B. You all know this. Next one, consider the earth is revolving around the sun in a circular orbit with a period t. The area of the circular orbit is directly proportional to, okay, so it is revolving around the sun in a circular orbit. Now the area is directly proportional to, what we say, t square would be proportional to r cube, area is proportional to r square, and r is proportional to t ki power 2 by 3, so it becomes t to the power 2 by 3 whole square. So area is proportional to t ki power 4 by 9, I can say. So it becomes, wait a minute, 2 by 3 whole square, not 4 by 9, sorry, it would be 4 by 3. It would be the wrong one to do on my part, so it would be t to the power 4 by 3. So go for option C here. Next, 6 identical conducting rods are joined as shown in the figure. A and D are maintained at 200. So I could do it by analogy of current. Let's say this is 200 volt, this is 20 volt. 6 identical, so R. So it's a balanced Wheatstone bridge. Fifth one is not needed, so it would be R. So effective resistance is 3R. So what we'll have now, this is R, this will also be R, and this will also be R. This is 200, this is 20, this is B, this is C, so drop would be equal. Total drop you know is 180, so drop across 1 would be 60, so it would be 140, and this would be again drop of 60, that would be 80. So you are asked for B would be 140 degrees Celsius. No issues in that, that's an easy one for you. Next, when an ideal gas with pressure P and volume V is compressed isothermally to 1/4 its volume, the pressure is P1. When the same gas is compressed polytropically according to the law, PV to the power 1.5 constant to 1/4 of its initial volume, the pressure is P2. The ratio of P1 by P2 is. Now when isothermally you make it 1/4, then P1 definitely would be 4 times P, because PV is constant. Now in the second case, what you have, PV to the power 1.5 would be equal to P2 into V by 4 ki power 1.5. So P2 would be equals to P into 4 ki power 1.5, or you can say 4 ki power 3 by 2, or 2 square into 3 by 2, that is 2 cube, that is 8P. So the ratio of P1 is to P2 you can directly say is equal to 1 is to 2. So again, not a tough one, you can do this. Next, given quantity of an ideal gas, it is at pressure P and absolute temperature T, the isothermal bulk modulus. So what is bulk modulus? First of all, you remember bulk modulus is defined as minus V dP by dV, and in isothermal process dP by dV is minus P by V, so it comes out as plus P. So bulk modulus is P. You all know this thing, this is asked here, and for just remember, for adiabatic process it is gamma times P. Next, we have a galvanometer of resistance 25 ohms. It is shunted by a 2.5 ohm wire. The part of the total current that flows through the galvanometer is, so now what you have, this is like shunted. Now this is 2.5, this is 25. So the part of the total current I0, so total current is I0. Now how will it divide? Because it is 1/10, so I will say this will have the 10 by 11 part, and this will have the 1 by 11 part. So it is I0 by 11, this is 10 I0 by 11. Directly you can make out. So the through the galvanometer would be you can say 1 by 11 part, that is part A is the right answer. Next, two long parallel wires are placed 0.08 meters apart, carry current 3 and 5 in the same direction. What is the distance from the conductor carrying the larger current to the point where the resultant field is 0? Okay, so this is 3 ampere, this is 5 ampere. Okay, carrying the larger where the magnetic field is 0. So the magnetic field becomes 0 at which point, okay, better I should write it, draw them like this. Let's say both are carrying like this, 3 ampere, 5 ampere. This would be better for me. Now this is the point where the field is 0. Let's assume, actually it would be closer to 3, 1. Let's say this distance is x, this would be, I can say, d minus x. So here we can make out both fields are opposite, so their magnitude must be same to cancel out. So mu naught into 3 upon 2 pi. So we have to calculate the distance from the larger one, so reverse it, it would be better. Take it to be x, take it to be d minus x. So 2 pi into d minus x would be equal to mu naught into 5 into 2 pi into x. So this 2 pi goes, so 3x is 5d minus 5x. Because you know x is less than d, I can directly write this. So what we have, 8x is 5d, so x is equal to 5d by 8. And what is d? D is 0.08, so it comes out as 0.05 meter. So go for option C, that is the appropriate one here. Okay, now the next one. There are 4 lightweight rod samples A, B, C, D separately suspended by a thread. A bar magnet is slowly brought near each sample and the following observations are made. A is feebly repelled. Repelled mean I can directly say it is diamagnetic. That is for sure. So A is of diamagnetic, no option like that. Okay. B is feebly attracted, that means it is para. So B is para. So B is of a paramagnetic, this is A. I got. C is strongly attracted, that means it is ferro. And D remains unaffected, that means it is a non-magnetic one. So option A is appropriate only. Next, the 1D motion of a point particle is shown in the figure. What you are given? You are given the speed time graph. Okay, it should not be speed, it should be velocity, otherwise it cannot be negative. So take it. The total distance traveled by the particle is 0. Total distance can never be 0. Total displacement, you can make out this area is positive, this area is same and negative, so the total displacement is 0. So go for option B, no need to go for other options, you are directly seeing it. Now, distance between a frog and an insect on a horizontal plane is 10 meter. The frog can jump with a maximum speed of root 10. Okay, the minimum number of jumps required by frog to catch. So what I can know, R max is at 45 degree, that is u square by g. That would be equal to 10 by 10, that is equal to 1 meter. So maximum it can jump as 1 meter, so minimum jumps will be 10 for sure. It can't go more than 1 meter in a jump. Next one. A symmetrical uniform solid cube of side 5 meter, okay, of side 5 meter is placed on a horizontal surface beside a vertical wall, one side of the cube making an angle 45 degree with the floor as shown. Okay, if the friction coefficient is mu is same for both wall and floor, the minimum value of mu so that the cube does not slip is. Now here, because of this 45 degree angle, let me first draw, let's say this center would be here, so mg acts like this, so this line of action passes through this, and this normal will also act like this. And because there is nothing in the vertical, if I can say if both are equal, the vertical forces are balanced, and because it is managed at this would be a position of what we generally say to be an unstable equilibrium, but it could be in equilibrium at this point, and there would be no pushing on this wall, so no friction here and no friction horizontally needed because this wall is not pushing, but it is only for a particular moment. If you slightly tilt it, then the normal and friction will come, but because it has asked for minimum value, I'll go for mu equal to 0 for this possibility. Next, the pulley arrangement in the figure A and B are identical. Okay, this is a very general question. I can see the mass of the rope is negligible. In A, the mass m is lifted by attaching 2m to the other end. In B, V is lifted by applying directly a force 2mg. So here what we have, here this 2mg comes, but it comes with a liability of 2m mass. So here treating it as a Atwood machine system, for the first one, acceleration would be net force 2mg minus mg along the length of the string divided by 2m plus m. If you directly know that, we see it along the length of the string, it will try to pull this and it will go up. So this mg is helping, this mg is obstructing, so it would be g by 3. Now this would be g by 3 down, this would be g by 3 up. In the second one, directly tension is equal to this 2mg, so this T is acting here, so what I can write, T minus mg upon m. T is 2mg, so 2mg minus mg upon m, that is g. So there the acceleration is g, so the answers would be g by 3 and g. Go for option B. This is a very common question, almost taught by all the institutes in India. 8 gram of copper 66 undergoes radioactive decay, and after 15 minutes only 1 gram remains. 8 to 1, that is 1/8. What is 1/8? 1/8 you means, that is 3t half. So 3t half is 15 minutes. So half-life, that's an easy one for you, that is 5 minutes. Nothing to do much in this question. Next, in the beta plus decay process, the following changes take place. In beta plus, you know, the atomic number decreases by 1 while the mass number remains same. So mass number, atomic number will change, so it will be false, it will be false. And here atomic number doesn't increases by 1, it decreases. In beta minus it increases, here it decreases, so I'll go for this, plus a positron, and this particle is this photon will be emitted. So this would be the equation that we would be talking about. Okay, so A is the most appropriate option here. Next one, what is the spring constant for the combination? Here you can directly make out this K and K are in what you can say in parallel, plus this 2K is also in parallel, because see, if this depresses it by X, so it will extend it by X, it will exert a force Kx upward, it will exert a force Kx upward, and because it is extended, it will also exert a force 2Kx. So both will act here, so all three are in parallel, so the equivalent would be 4K. Next, if a simple pendulum oscillates with an amplitude of 50 millimeter and a time period of 2 seconds, then the maximum velocity is. So here directly you can say Vmax is omega times A. Omega would be 2 pi by 2 into A is 50 into 10 to the power minus 3. So what do you get? 50 pi into 10 to the power minus 3. So what we can have, 5 pi into 10 to the power minus 2, pi is 3.14, so 3.14 would be 5 into 3.14 into 10 to the power minus 2, 5 4s are 20, this is 7, this is 15.7, so I can write it as 0.1570, that would be the better one. So it is 0.15 meter per second, that I can go for option B. Next one, the de Broglie wavelength of a neutron at 927 degrees lambda. What would be the wavelength at 27? We know lambda is h by p. P is root 2m e. here is what you can say, that is 3 by 2 kt because of temperature. So lambda is inverse to 1 by root t. So what you have, lambda upon this lambda dash would be root of 27 means 300. Reverse we have taken 927 means this is 1200. So it is 1 by 2. So lambda dash comes out to be 2 lambda. So go for option B. Again, this is a regular one. You all have done such questions before, I suppose. Next, the photoelectric threshold frequency of a metal is nu. Okay, when light of frequency 4 nu is incident, the maximum kinetic energy is. What you have to solve here? You indirectly say K max is E minus phi. E is h times 4 nu and threshold frequency is nu, that is h nu. That comes out as 3h nu. So I have just solved it for you, otherwise I would directly take it as 3h nu. Next, the Young's modulus of a material is 3 times of its modulus of rigidity, then the volume elasticity will be. Now this relationship typically I don't teach to my students because I don't expect it to come, so you might get questions here. So because we have got a question, just remember this: Young's modulus is 9 times the bulk modulus into shear modulus divided by 3 times the bulk modulus plus shear modulus. This is a relation you can remember. Generally I don't say because I don't believe it's actually a part of your syllabus. Generally it is not given in your NCERT, plus not at all required, but this question has come, so I am helpless here. So what would be the volume elasticity, that is the bulk modulus here? So if I rearrange it, what I can have, 3yb plus ys is equal to 9bs. So what we can have for the bulk modulus now, so divided by b here, so 3y plus ys by b is equal to 9s. So ys by b is equal to 9s minus 3y, or bulk modulus is ys upon 9s minus 3y. So what we have, Young's modulus is 3 times of its modulus of rigidity. So this would be become 9s minus 9s, that is something upon 0. So something upon 0 is basically infinity. So bulk modulus here is infinite. That is what you can write, nothing else you can say. So this bulk modulus is going to be infinite. But again, this I don't think that's a right way question to ask to you students. The work done in blowing a soap bubble of 10 centimeter radius is. So now the work done is equal to the change in energy, that is S into A, and because it is a bubble, double surface would be considered, that is 8 pi r square into surface tension. So surface tension is given as 3 by 100, 8 into pi, and r square, that is 0.1 square, 10 to the power minus 2. So what you have, 10 to the power minus 4 into 24 pi, and pi is 3.14, so it is 72 something, so 75.36 into 10 to the power minus 4 joule would be the answer. Next one, a convex mirror forms an image 1/4 the size of the object. Okay, and because it is convex mirror, m would be plus 1 by 4, no doubt, because it is a erect image, so magnification is plus 1 by 4. If the object is a distance 0.5 from the mirror, the focal length of the mirror is, and magnification is minus f upon u minus f, you remember. So 1 by 4 is minus f, u is minus 0.5 because it is negative, minus f, so negative all cancelled, 1 by, this will be f upon 0.5 plus f. So 0.5 plus f is equal to 4f. So 5f is equal to 0.5. Sorry, it would be 3f. So 3f would be equal to 0.5. So f is equal to 0.5 by 3, that is 0.17 meters. So focal length would be 0.17 meters for this particular case. Next, light has a wavelength 600 nanometer in free space. It passes into glass which has an index of refraction 1.5. What is the frequency of the light? The frequency of the light will remain the same that was in the free space, that was 3 into 10 to the power 8 upon 600. Just remember, frequency doesn't change, speed and wavelength changes. Into 10 to the power minus 9. So what you will have, 8, and this would be 7, 20 to the power 15 into 1 by 2, that is 4 into 10 ki power, 5 into 10 ki power 14, 1 by 2 would be 0.5, so 5 into 10 to the power 14 hertz. Next, a disk of the moment of inertia I1 is rotating in a horizontal plane about an axis through a center and perpendicular to its plane with angular speed omega 1. Another disk I2 having 0 angular speed is placed coaxially. Both are now rotating with constant angular speed omega 2, the energy lost. So it is a classical problem of angular momentum conservation. What you will say, no external torque acts about axis, so I1 omega would be I1 plus I2 into omega 2. So omega 2 comes out as I1 omega 1 upon I1 plus I2. So initial kinetic energy was half I1 omega 1 square. Final kinetic energy would be half I1 plus I2 into omega 2 square. Omega 2 square would be I1 omega 1 upon I1 plus I2 whole square. So it comes out as half I1 omega 1 whole square upon I1 plus I2. Okay. So the loss would be K initial minus K final. So what I can write, half I1 omega 1 square common, 1 minus I1 upon I1 plus I2. So it comes out as half I1 I2. Let me write it more clearly. It would be half, it will be I2 there, so I have I1 I2 omega 1 square upon I1 plus I2. So what we have now, as per the available options, this option is where it is here, option D. Next, 36. A body rolls down an inclined plane. If its kinetic energy of rotation is 40% of its kinetic energy of translation, then the body is okay. So what we have, Kr is 40%, that is 0.4 times the Kt. Okay, so what we can say, this is Kr is 0.4 times Kt and total kinetic energy is Kr plus Kt. So that comes out as 1.4 of Kt. That means simply we'd simply write it as beta times Kt. So that beta factor is 1.4. Beta we know is 1 plus K square by R square. So K square by R square is 0.4. That is what we are getting. So K square by R square is 0.4, or you can say it is 2 by 5. So 2 by 5 mr square you know is for the solid sphere. So the answer would be option B for sure. Next, for a CE amplifier, the audio signal voltage across the collector resistance is 2 volt. That is V output is 2 volt. If beta is 200 and base resistance is this, the input signal voltage is. So what we know, voltage gain is beta RC by RB, that I can write, that is VO by VI is a voltage gain, that is beta RC by RB. As per the data, VO is given, beta given, RC RB given, so VI I can calculate. So VI directly you write now as V naught into RB upon beta RC. Put the values. 2 volt, this is RB is 1.5 kilo ohms, this is 200 and this is 2 kilo ohms. So this would be 3 by 4 and this would be 2 cancelled, so it is what we have, 3 upon 400. So 3 upon 400 means it would be 0.0075. So 0.00, and let me write it clearly, this would be 0.0075 volts. That is this. So we are left with only one option. You can calculate the current also from there, it will come out to be the same. Next one, in a system of two polarizer, it is found that the intensity of the light from the second polarizer is half from that of the first. So what it says, I2 is I1 by 2, which should be equal to I1 cos square theta, angle between 2, that is cos square theta is half, that means cos theta is 1 by root 2, so angle is 45 degrees. So again it's an easy one. Next, gas is filled in a cylinder. Its temperature is increased by 20% on the Kelvin and volume is reduced by 10%. So how much percentage of the gas has to leak for pressure to remain constant? Now pressure is nRT by V. So pressure should remain same. So I can, let's say, equate both the times. So N1 R T1 upon V1 should be equal to N2 R T2 upon V2. So this R and R goes. So N2 would be N1 into T1 upon T2 into V2 upon V1. Now as per the data, temperature is increased by 20%. So this is T1, so this would be 1.2 T1. And volume is reduced, so it would be 0.9 V1. Okay, so what you have, N1 into this will be 3 by 4. So N2 is 3/4 of N1, that means 25% of the air has to get leaked. 25% moles have to be leaked out. Next, choose the wrong statement for zero error and zero correction. Okay, again this is a measuring instrument. If the 0 of the vernier doesn't coincide with the 0 of the main scale, then the instrument is said to be having a zero error. So this is a right statement, so this won't be the answer. Zero correction has a magnitude equal to zero error, but sign is opposite to that of, yes, this is correct. Zero error is positive when the 0 of the vernier lies to the left of the 0 of the main. No, it is positive when it is right to the right. It would be like this. This is the main 0, this vernier 0 has to be like this for positive error. So this one is wrong, that means this would be my answer. And again, so the D1 is right from this logic, so C is the answer here. Next one, in YDSE, if the separation is half between the slits, the distance between the slits and the screen is doubled than the fringe width. So fringe width you know is lambda d by d, you all know. This d is what you have doubled and this you have done is halved, so it will become 4 times, so it is quadrupled. You can directly say it's an easy one. Next, two coherent point sources S1 S2 vibrating in phase emit light of wavelength lambda. The separation between them is 2 lambda. The light is collected on a screen placed at a distance d greater than lambda from the slit S1 as shown the minimum distance so that the intensity at P is equal to the intensity at O. Okay, so they are vibrating in phase, separation is 2 lambda. Now the minimum distance so that the intensity at P is equal to the intensity at O. So at O you see this light goes like this light goes like this, their gap is 2 lambda, therefore there is a maxima. So now for P to be maxima, this gap has to be lambda, this gap, this S1 and this S2, this gap has to be lambda. So treating them like the analogy that we did, let's say we know this gap is 2 lambda. So if I go at this point P and this gap has to be lambda, I can make out again that the rays will almost be parallel because the gap is very large. So if I draw the perpendicular, this would be the distance. So because this angle is theta, that I have already told you, so because this angle was theta and this is the angle between this and this, so this is the normal to this, and again if I draw this vertical, this angle would be theta again. So this angle would be what you can say is okay, so this is 90, so this angle is again theta that we are getting. So because this is theta, this angle will also be theta. So if I make this distance part difference delta x, it would directly be equal to delta x would be equal to 2 lambda cos theta, and that should be equals to lambda. So 2 lambda cos theta must be equals to lambda here for sure. So what it says, 2 lambda cos theta is equal to lambda. So cos theta comes out as 1 by 2. So what do you need? This distance. Now this distance, what is this particular distance? So first of all, cos theta is 1 by 2, you know, at 60 degree. So theta comes out as 60. So let me draw this figure again. So this angle comes out as 60 degree. This is y and this is approximately d because d is greater than lambda. So what I can write, 10 of 60. 10 of 60 degree is equal to y by d. So y is equal to, you can directly say is equal to root 3d. So we'll go for option B here. So just using that YDSE rules, you can do this here also. Next, consider the vehicle emitting sound wave of frequency 700 moving towards an observer at speed 22. Assuming the observer as well as medium to be at rest and velocity of the sound be this, the frequency of sound as measured by observer. So it's a straightforward question. Frequency f dash apparent would be f naught. Because source is moving, observer is at rest, it would be 330 and observer is source is going towards this, therefore 330 minus 22 I can write. So it would be 700 into 330 upon what we have now, 308 I can write. So if 7 comes, yes 7 comes, so 100, this would be 444. So now 44, this is 11 table, this is 30, this is 4, this is 25, so 30 into 25 comes out to be 750 hertz. So it's a straightforward option D. Now the 44th, the electric field portion of EM wave is given by, okay, the frequency, you know, this is omega. So omega comes out as 6 into 10 to the power 5, so frequency is omega by 2 pi. So that comes out as 6 upon 2 pi into 10 to the power 5. So in kilohertz I can write it as 600 upon 2 pi kilohertz, which comes out as 300 by pi. So not 30 by pi, this is 300 by pi. Only one option is remaining. You can check for the other one also. I can make for the first one only. Next, a light and a heavy body have equal momentum. Which one has greater kinetic energy? What do you know? Kinetic energy is p square by 2m. So for equal momentum, k is inverse to m. So lighter one will have more. So lighter body will have the more kinetic energy. So this was the paper today. Keep watching, keep sharing the channel. Thank you once again.